Hi, everybody. Welcome back to week number 8 of e-learning. Last week was a shortened week for science and math, but the week prior to that, we introduced atoms. So what were the three little parts that are found inside of every atom? They are positive protons, neutral neutrons, and negative electrons. Those protons, neutrons, and electrons are going to be really important inside of each atom. When you worked with the M&M lab, you had 3 protons, 3 neutrons, and 3 electrons. That was representing the element lithium. It was one tiny little atom of the element lithium. Now, how did I know it was lithium? It's because every single element on Earth has its own unique number of protons. What do I mean by all of this? Elements, atoms, protons, neutrons, and electrons. Well, this week I'm going to introduce the periodic table of elements. So if you haven't done so, you need to go and find your textbook that you got at the very beginning of the year, and you're going to open up to pages 84 and 85. If you don't want to dig that out, find the laminated copy that was sent home probably 2 weeks after the book had arrived. So each one of the tiny little squares on this periodic table of elements represents all of the known elements on our Earth. In fact, it's all of the known elements that we know of in our universe. There's like 120 different elements, and a hydrogen element, the element hydrogen, is different from the element helium only because of the number of protons. So let me start off here by sharing my screen, and I'm going to give it a little bit of history on the periodic table of elements here. There we go. I got that brought up. So the big question today that we'll start with, it says, what did Dmitri Mendeleev discover? Well, Dmitri Mendeleev, he was actually a Russian chemist. He lived from 1834 to 1907. And it was in the mid 1800s, actually around 1870, that he had taken all of the known elements at that time, and there were about 65 of them, and he put each one of them on their own unique index card, and he wrote the name that they had given them. He wrote their mass that they had calculated and any other properties that they knew about that element. He spent hours upon hours trying to arrange those elements so that they made some kind of a pattern. He tried to arrange them by their mass. He tried to arrange them by how they reacted to things, their color, what they would combine with easily. And eventually, now it's just a little story about that. Eventually, when he arranged them in order of increasing atomic mass, he saw a pattern. And the pattern that he came up with created today's periodic table of elements. Now, the periodic table that you're looking at right now has 118 elements. He only had 65 elements to work with. So he had gaps in his periodic table, and he made predictions, you know that word from the beginning of the year, he made predictions about what the elements would be like that would fill in the gaps. And ever since then, as we've discovered new elements, sure enough, they've fit right into the periodic table. Now, here's the thing. Mendeleev, he arranged it originally by their mass, their atomic mass. It turns out that that wasn't quite right. There are a few elements here that would be out of order based on their atomic mass. Instead, today's periodic table of elements is arranged by their atomic number. And the atomic number in this periodic table, it's the little number in the upper left-hand corner of each of the squares. On your chart, if you go to the element hydrogen in the upper left-hand corner, the number 1 is in the top right corner, and that is its atomic number. Now, the atomic number, what you'll get from the reading that you're going to do after you watch my lesson, you're going to read page 83 in your textbook, and you're going to see what the difference is between atomic number, the chemical symbol, and the atomic mass. So if I click over to the next slide, each one of those little tiles on your periodic table of elements has the atomic number, and sometimes it's in the upper left, sometimes it's in the upper right. It's going to have the symbol, so the letter H represents the element hydrogen, and underneath it, it's going to have its atomic mass. Now, the mass of an element is the protons plus the neutrons. The atomic number is just the number of protons. This week, you're going to be playing with, let me stop my screen sharing. You're going to be playing with the PhET simulation. All right, so you're going to be playing with the PhET simulation this week. So this will be the class pages that you're looking at this week for science. First thing you'll do is watch this video lesson. Next thing you'll read out of the textbook, page 83. Remember, you have to do these things in order. If you start with the simulation or the lab, it's not going to make any sense. You're going to watch this amazing music video on the periodic table of elements right here. And then you're going to open the phet.colorado.edu simulation and the lab sheet that goes with it. And they are right down here on the bottom. So I'm going to open up the simulation. You're either going to click this button to start it, or you might have to download it. Try to click the button first, though. And these are simulations that were made up by students who go to the University of Colorado. It's free simulations. You can go on it and play with all the different things. You're going to open up the atom. And what you've got here is a blank atom. Now, hopefully you remember what goes in the nucleus. Do electrons go in the nucleus? Nope, they don't go into that nucleus. As much as I try and stick them in there, the electrons go into this outer edge, which we call the electron cloud. But the protons and the neutrons do go inside the nucleus. So I'm going to reset it here. When you work through this simulation in the lab for this, you've got your periodic table of elements is in the upper right-hand corner. Every time I put a proton on, it tells me what element it is. Now, if I don't remember what H is, it tells me that it's hydrogen, or I can go to my periodic table of elements that you have in your book or the laminated copy. Look what happens if I add a second proton. The name of my element changed. That should be a clue as to what the difference is between a hydrogen and a helium. If I add a third one, now we've got lithium, and this is representing the elements or the atoms that you made with the M&Ms 2 weeks ago. I can add neutrons, neutral neutrons. Okay, the number of neutrons that I'm going to add, I'm going to figure that out by going down here, and I'm clicking on the stable versus unstable. And if I clear my atom again and I add my 3 protons to get to lithium, and I click stable, unstable, I have an unstable lithium ion. What that means is it would be radioactive, and you wouldn't want to be anywhere near it. As I add neutrons to it, my element suddenly becomes stable. So I know exactly how many neutrons I need to make my element stable. Now, the next thing you're going to look at is the net charge. So I clicked over here on this yellow box that said net charge. And over here, I see a little plus. And this little meter is tilted towards the plus side. That's telling me that my element or my atom is positively charged. That means I'm missing something in my atom. And what I'm missing is the negatively charged particles that help to stabilize my atom. So I'm going to, or equalize the charges of my atom. So let's see how many ions I need to, or how many electrons I need to add to give my lithium atom to make it neutral. So it looks like I needed 3 electrons, 3 negatively charged electrons to balance out my 3 positively charged protons. And you can see the little meter over here now has balanced itself out. The last thing you're going to play with on this simulation is the mass number. And the mass number down here, you're going to work with this 6. And when I go to a lithium atom, or the lithium element in my periodic table, I see down below it says 6.941. Well, down here I've got 6. This lithium can actually take 1 more neutron, and it bumps that mass number up to a 7, which 6.941 rounds up to 7. So the average lithium element or atom that we would find naturally occurring out there is going to have 3 protons, 4 neutrons, and it needs 3 electrons to make it neutral. Okay, so this week, remember, you're watching my video, reading out of your textbook, watching the music video, playing around with this PhET simulation and your lab, and then you're going to turn it all into the Dropbox. One last thing this week, and it's on Wednesday. You guys are, no, I'm sorry, it's on Tuesday. After your social studies Zoom with Mrs. Eaton, you're going to come back to my class pages and you're going to get on a Zoom. And I've been asked to conduct this NWEA science assessment. What this thing is, it's going to be a series of science questions that I need you to take it seriously, and I need you to answer them to the best of your ability. I'm not grading you on it, but what I'm getting out of it is what I need to go back and reteach. And it could be material that I need to reteach from last year, or material that I need to reinforce from 6th grade, 5th grade, 4th grade on down. It's important to me. It's important to what I'm teaching the rest of this year that I get an idea of where you are with science. So you got all week to work on this stuff. Tuesday, I need you to come to that NWEA assessment and stop into my office hours, 11 o'clock, 1 o'clock, 2 o'clock. Pop in. I'm more than happy to help you guys. So I hope that you have a good week. I'm hopeful at this point that we are back to school in the next couple of weeks, because I miss you guys a lot. I can't wait to see you face to face every single day. All right, good luck, and I will talk to you.